So we have taken great care to, first of all, perform accurate calibrations as well as validate our data against many different independent sources. So for a microwave sounder or any microwave radiometer, there's an intrinsic measurement of the instrument's noise. That's called the noise equivalent delta temperature, NEDT. And this is just the basically pixel to pixel noise level that we observe in that instrument, how much variation there is if it were looking at a purely uniform scene. Then for the validation, we see how well the measurement is comparing to what we would simulate from that other validation source. So we have, if we wanted a validation everywhere, we would use a model reanalysis. So this is a model's estimate of the state of the atmosphere that we can simulate our measurements from. And that model is not going to be perfect because it doesn't have measurements. It's not assimilating TMS data. So it's relying on numerical weather prediction to propagate the state of the atmosphere properly. And so there is going to be some error. It's never going to be a perfect match. In particular, it doesn't handle clouds very well. So we do screen out clouds from these analyses. And depending on the channel, some channels are we're getting very close to the NEDT. Other channels that are more sensitive to clouds and water vapor don't do quite as well. So that's what you see in the orange bars there. But another thing we can do is validate against other satellites directly when our satellites pass over a location at the same time as these other satellites. So we picked two satellites that are known in the community to be very well calibrated. Those are the ATMS instrument aboard the NOAA polar orbiters and the GMI instrument on NASA's GPM mission.